as sarcopterygian fish transition from living in aquatic environments to being adapted to land and evolving into the first amphibians, obviously this affected their senses. The perception of sound in air is different than in water, and as one observes the otic region of the skull in sarcopterygian fish, one can see that it was actually being modified to be better able to perceive sound in terrestrial environments and is intermediate between the ear region of the first amphibians and those of earlier sarcopterygian fish. The ear certainly wasn't finished by the time of the ancestors of modern tetrapods. And as we compare tetrapods alive today, their ear region and their perception of sound varies. So for example, salamanders and snakes lack the tympanum or eardrum possessed by their relatives, frogs and lizards, respectively. When the first reptiles or amniotes evolved, in amniotes, the region of the inner ear known as the Legena is lengthened. This is derived from the vestibule and is specializing in the perception of sound, although in fish, the vestibule and perhaps the lateral line system as well can also perceive sound. This Legena coils and becomes the cochlea of mammals. Amniotes also develop an external ear region with a canal directing sound towards the middle and inner ear with an external auditory meatus. Once again, the ear was not complete in the first tetrapods, and what we think of as the tympanic ear, where an eardrum vibrates and transmits sound to an inner ear, this actually evolved multiple times in tetrapods. Skull bones could be modified so that in addition to providing support for the skull, they were also then vibrating and helping with the transmission of sound vibrations towards the middle and inner ear regions. These stapes became the single auditory ossicle in reptiles. And as one looks at ancestral amphibians and primitive reptiles, one can see various levels of modification of the stapes as it transitioned from a bone which also supported the skull to one primarily devoted to the transmission of sound vibrations. Much of the tympanic ear of mammals evolved separately from those of other lineages of tetrapods. The Legena, which would become the cochlea, lengthened and in most mammals coils, and significantly two bones that made up the reptilian jaw joint, the quadrate and the articular, here depicted in yellow and red, were modified in mammalian ancestors so that they no longer functioned in the jaw joint, which then became between the dentary and the temporal bones, the squamosal portion. And instead, these yellow and red bones were now freed so that they could be incorporated into the middle ear, where they became the malleus and incus, which only mammals possess, which amplify the vibrations of the tympanum along with the ancestral stapes. So mammals have three auditory ossicles compared to, say, reptiles, which have one, and this makes their hearing much more acute. In mammalian embryos, one can still observe these small bones transition from the jaw region to the middle ear. In most mammals, the external ear includes a piece of cartilage, the pinna, which helps direct sound waves towards the external auditory meatus. This can obviously take different shapes in mammals as varied as elephants and dogs and humans, but the greatest variation is observed in bats, where bats evolved as specializations which allowed echolocation. This occurred after the first bats, which are the ancestors of, say, the megachiropteran bats like flying foxes today, which do not practice echolocation. In echolocation, high-frequency sound waves are emitted through the nose, and as they bounce off things in the environment, the highly specialized ears then detect this and allow navigation. Other mammals, such as marine mammals like whales and seals, would also then develop types of echolocation. So in conclusion, vertebrate ears have changed over hundreds of millions of years and have been adapted to diverse functions.